This is Cambridge IGCSE for Chemistry, Paper 4, Theory, Variant 2, October-November 2023. Question number 1. Table 1.1 gives the electronic configurations of some atoms and ions A to G. Answer the following questions about A to G. Each letter may be used once, more than once, or not at all. State which of the atoms or ions A to G could be a noble gas atom. A noble gas atom should have a full outer shell electron, so B. An atom of an element in group 6, which is having 6 valence electrons, that will be F. An atom with the atomic number 14, so it's an atom, so proton and electrons are the same, making it a neutral atom. So it has 14 electrons arranged in 2, 8, 4, so D. Next, atoms from the same group should have the same number of valence electrons. So as you can see, it is A and E that have the same number of valence electron. A halogen atom, halogen comes from group 7, so valence electron 7, G. An atom of an element which is a good conductor of electricity, so it will be a metal. A metal can be found in group 1, group 2, transition metal block. So C, which has 2 valence electrons. A stable ion of a group 5 element. Okay, a stable ion of a group 5 element. So you have to know that group 5 forms -3. Okay, group 5 ions form -3. So let's say, for example, nitrogen is 2, 5. It will form a nitrite ion, 2, 8. So the ion will be B, right? Will be B. If it's formed from A, but then the ion is B. An atom that forms an ion with a -2 charge. So that will be, what forms -2? Group 6. Which one has 6 valence electron? F. Next question. Cobalt and copper are transition elements. Copper has 2 naturally occurring isotopes, copper 63 and copper 65. Cobalt has only 1 naturally occurring isotope, which is cobalt 59. Complete the table to show the number of protons, neutrons, and electrons in both particles. Okay, cobalt is, I have to look at the periodic table. Cobalt is element 27. Copper is element 29. Look at the periodic table to find the protons. Neutron, pick the big number minus proton. So you get 32 for the first part. Then second, take the big number minus the small one, you get 36. Then electrons, look at the charge. The first one is an atom, proton and electrons are equal. The second one is a cation ion. So 2 more protons and electrons, so it will be 31. No, sorry, 27 electrons. Next, the table shows the relative abundance of the 2 naturally occurring isotopes of copper. Calculate the relative atomic mass of copper to 1 decimal place. This one also, essentially relative atomic mass is just like calculating mean mass. Alright, mean mass of the atoms. So to find the mean mass, or should I say the relative atomic mass, simply take the percentage abundance multiplied by the mass, sum them together, then divide by 100. That makes a grand total of 6360 divided by 100, you get 63.6. Next, one physical property of transition elements such as copper and cobalt is that they are hard. Other metals such as lithium are softer. State 2 other physical properties of copper and cobalt which are significantly different from lithium. So in terms of physical property, they have way higher density, they have way higher melting point than lithium. Next, both copper and cobalt can form colored compounds. Some of these compounds contain water of crystallization. Define the term water of crystallization. So it is the water molecules that are present in the hydrated crystal. State the color and the formula of hydrated cobalt 2 chloride crystal. So the color is pink. Cobalt 2 chloride crystal, in terms of hydrated, it is COCl2.6H2O. Next, state the color change when seen when a few drops of water are added to anhydrous copper 2 sulfate. So this is from white to blue. How can you reverse this? By heating the hydrated copper 2 sulfate. Next, iron is manufactured in the blast furnace. Three of the starting materials are added to blast furnace are coke, iron ore, and limestone. Name the other starting material that are added to the blast furnace. Air, hot air. The source of iron in the blast furnace is Fe2O3. It is found in the iron ore. Name the main ore of iron which contains Fe2O3. That is your hematite. Next, the iron trioxide is reduced by reaction with carbon monoxide. The unbalanced symbol equation is shown. Complete the equation. So we have two ions. Then we have three oxygens. So it will be three carbon, and six oxygen on both sides. State the change in oxidation number of iron in this reaction. So iron went from +3, because +3 -2 combination makes 2:3 ratio, and then to a neutral atom, which is 0. Explain how the oxidation number shows that the iron has been reduced because it decreases. The major impurity in iron ore is silicon fluoroxide. Limestone is added to the blast furnace to remove this impurity. Write two symbol equations to show how silicon fluoroxide is formed. For each equation, state the type of chemical reaction that takes place. So equation one, we are having the thermal decomposition of calcium carbonate, which is limestone, to form calcium oxide and sulfur dioxide. And carbon dioxide, my bad. This is called thermal decomposition. Then equation 2, we have calcium oxide reacting with our silicon fluoroxide, forming calcium silicate, which is also known as slag. This is actually a neutralization reaction. Or you can call it an acid-base reaction. Okay, because this is a metal oxide, which is a base. This is a non-metal oxide, which is an acid. Next, iron is converted to steel by mixing it with carbon and other elements. Steel, the term given to a substance in which a mixture of a metal and other elements, there will be an alloy. Name one element other than carbon mixed with iron in the making of stainless steel. So stainless steel, right, it can also contain chromium or nickel. Preventing the rusting of steel is important. State the chemical name of rust, that is hydrated iron trioxide. Next, steel can be coated with zinc to prevent rusting. This provides both a barrier method and sacrificial protection. State the term used for coating steel with zinc: galvanizing. Describe another barrier method for prevent rusting. You can use coating with plastic, coating with paint, right, or greasing. Okay, next question. Explain how zinc provides sacrificial protection. Because zinc is more reactive than iron, which means that it will corrode first instead of iron. Okay, next. This question is about lead-2 chloride. A student prepares a sample of insoluble lead-2 chloride by mixing aqueous solutions of two salts in a beaker. Identify the two soluble salts suitable for making lead-2 chloride when mixed together. So you want to make lead-2 chloride, you need something that carries lead, you need something that carries chloride. You can use, well, sodium chloride, and you can use lead-2 nitrate. Right, an ionic equation for the formation of lead-2 chloride by mixing aqueous solutions includes this symbol. This is a precipitation reaction, also known as insoluble salt formation. The state symbols are aqueous, solid reaction, in which our lead-2 ions are combining with chloride ions to form lead-2 chloride, and we need 2 chloride for that. Next, list the steps the student should take in preparing a pure sample of lead-2 chloride from the mixture in the beaker. First of all, of course, after the preparation is made, the student must filter, filter, so that you get the insoluble salt, which is known as the residue. Right? Of course, before you collect the residue, you have to wash with distilled water, because it might be stained with other soluble salts. Wash the residue with distilled water, and then dry the residue by using filter paper. That's how you get the precipitate. Okay, next, a student carries out an electrolysis experiment on molten lead-2 chloride using the apparatus shown in the figure. Chlorine gas is formed at the anode and escapes from the apparatus. Explain why lead-2 chloride needs to be molten before it will conduct electricity, so that the ions are now free to move. In solid state, the ions are not free to move, so it couldn't conduct electricity, so it must be melted first. Then only the ions are free to move, so it can conduct electricity. Write the ionic half equation for the reaction occurring at the anode. At the anode, it will be the non-metal that gets discharged. Our chloride ion is undergoing oxidation. Anode is the site where oxidation takes place, where electrons are given. So it forms electrons and chlorine gas. So 2 electrons, 2 chloride. Take the test for chlorine gas. Take a damp litmus paper, and it will turn white, or should I say it will be bleached. Describe what is observed at the cathode. We know that lead-2 will get discharged at the cathode, will get reduced at the cathode, so you will form gray solid, silvery gray solid. Right? Is it silvery gray? Gray? I think silvery a little bit is not really accurate. Gray solid. Okay, next, chemical reactions can involve transfer of thermal energy. State the term used for the transfer of thermal energy during a reaction. Enthalpy change is the transfer of thermal energy during a reaction. Tetrachloromethane gas CCl4 reacts with steam as shown. The reaction is reversible. The forward reaction is exothermic. State what happens, if anything, to the forward reaction rate if the concentration of CCl4 is increased. Explain your answer in terms of collision theory. So, as concentration of CCl4 increases, we should expect to see the rate increases, rate of the forward reaction increases. Why? Because when you increase concentration, more particles per unit volume, which means that the frequency of collision increases. Frequency of collision between CCl4 and H2O increases. Okay, which leads to frequency of successful collision increases. See what happens to the position of equilibrium, if anything, when the pressure is increased. Explain your answer. So when you increase pressure, that will favor the side with less gas. So the left and the right, you see that on the left there's 3 gases, on the right there's 5 gases. So which side has less gas is the one on the left. It will favor the left hand side. The equilibrium position will shift to the left. Why? Because the left hand side has less gas particles. Alright? Or should I say the right hand side has more gas particles? Okay, next. Figure 5.1 shows an incomplete reaction pathway diagram for the forward reaction. On the figure, insert the formula of the reactants and products. Draw an arrow labeled EA to show the activation energy. Draw an arrow labeled delta H to show the transfer energy in the reaction. Okay, first of all, let's copy the reactants. So CCl4 and 2H2O turn into CO2 and 4HCl. Okay, next, activation energy. So it will be measured all the way from the reactants to the peak of the curve. Reactants to the peak of the curve. Now, whereas for energy change, because it's an exothermic reaction, product has less energy than reactants. So this will be the delta H symbol. This will be the EA symbol. Okay. This is measured between reactants and products for delta H. For EA, is measured all the way from the reactants to the peak of the graph. Define the term activation energy. The minimum energy required by colliding reactant particles to react. Pick one way in which the activation energy of a reaction can be changed by using an enzyme. Or should I say by using a catalyst. You can use catalyst, either inorganic or organic catalyst. So use catalyst. Next, the equation for the reaction between tetrachloromethane gas and steam can be represented as shown. The table shows some bond energies. Use the bond energies in the table and delta H for the reaction to calculate HCl bond energy using the following steps. Calculate the energy needed to break the bonds in the reactants. So we have 4 CCl bonds and we have 4 HO bonds. So altogether, (3,200 kilojoules). Next, calculate the energy released when the bonds in carbon dioxide form. So only carbon dioxide will be 2 times 805, which is 1610. Calculate the HCl bond energy. Okay, so delta H is bond breaking minus bond formation energy. Bond breaking energy is 3200. Bond formation, we know for carbon dioxide, which is 1610, but we don't know for certain how much is required to break 4 HCl bonds. So just, whereas for delta H is already given to you, it's negative 130. So just adjust the formula by doing it like mathematics, 3200 plus 130. Then I get 3330. So 4 HCl's make 1720. Each HCl bond makes 430 kilojoule per mole. Next, a homologous series is a family of organic compounds whose members have similar chemical properties. Give 2 characteristics that are the same for all members of a homologous series. So for the same homologous series, they have the same functional group. They have similar chemical properties due to the same functional group, but because it's given, so you cannot write that down. You have to use others. So you can talk about each member, each consecutive member differ by CH2, or you can say differ by relative mass of 14. Okay, you can talk about they have the same general formula. Oh wait, pause. Just give me a moment. Oh, I can't write this. Why? Because it says all members. Can I write that? I don't think I can. I can because of the question. Give two characteristics that are the same for all members of homologous series. All members. Yeah, it's not really the same. It's more like a pattern. So we can't say that. So two things, same functional group, same general formula. In terms of structure, state how one member of a homologous series differ from the next, which is our point just now, increased by a CH2. Right, differ by a CH2 unit. A, B, C are organic compounds. A has the molecular formula C12H24. B has the name tetradecane. C has 3 carbon atoms and is in the homologous series with the general formula CnH2n plus 1 COOH. Name the homologous series each organic compound belongs to. For the first one, as you can see, it has a 1 to 2 ratio for C to H. So that is actually an alkene. The next one, as you can see, it ends with A. It will be an alkane. And the last one, this homologous series formula, general formula, is for carboxylic acids. Next, name C and draw its displayed formula. So 3 carbon propanoic. 3 carbon will be propane, so propanoic acid. Displayed formula, 3 carbons. Draw the functional group, which is COOH. Make sure each carbon atom has 4 lines by putting them with hydrogen. Next, amino acids are a homologous series where each member has the general structure shown in figure 6.1. The R side chain contains carbon and hydrogen only. An amino acid has a relative molecular mass of 103. Deduce the formula of R side chain in this amino acid. Show your working. So, total mass is 103, which is R, the mass of R plus 4 hydrogen, 2 carbon, 1 nitrogen, and 2 oxygen. That makes a total of 103. So R is 4 hydrogen plus 74. So 103 minus 74, I get 29. Is that true? Yes, 29. What could that be? What could that be? Is it 14? 15? Yes, okay, so R could be C2H5 because this has the mass of 29. Okay. Next, state the name given to natural polyamides formed from amino acid monomers that will be a protein. And that's the end of the discussion. Thank you for watching, and I'll see you in the next one. Bye-bye.